Okay, here with problem 4, we do have a company has the following cost and revenue functions. We're asked to find the break-even points, and for what level of production will profit be maximized. While I copy those functions down, everyone, I'm going to pause the video so you don't have to sit through that. Okay, so I've got both of those functions copied down, and at this point to find the break-even points, and then I'm also asked to find the level of production that maximizes profit. I have two options to find the break-even points. I could put cost equal to revenue, or I could say profit is equal to 0. And so since I know I'm going to need a profit function for the next piece, I'm going to go ahead and calculate profit right now. And I remember that profit is equal to revenue minus cost. So I'm going to substitute my revenue in for R, which is 175 minus 1/2 x times x. And then I'm going to subtract the cost. Remember, this parenthesis right here is very important. So 3600 plus 25x plus 1/2 x squared. So everyone, I can give that to Wolfram. Unfortunately for this one, I can't copy and paste because this is a picture, not my typing, because of the fractions I had to put in there. And so I've got profit is equal to 175 minus 1/2 x times x minus, don't forget this parenthesis, 3600 plus 25x plus 1/2 x squared. And so the profit function that I'm going to get, everyone, is going to be negative x squared plus 150x minus 3,600. And these roots that Wolfram is giving me here are actually the break-even points, but we're going to inspect that a little bit more as we move on here, everyone. So again, to find break-even, I could do revenue as equal to cost, or I could set profit as equal to 0. And so here we see that our profit function is negative x squared plus 150x minus 3,600. To get the break-even, let's set that equal to 0. And see what we get. So we'll feed that to Wolfram. Again, you could do revenue equals cost, and that would produce the same result. I just chose to do this because it's, see, so the roots, or in this case, the solutions are 30 and 120. So we can say that break-even occurs when 30 or 120 units are produced and sold. Now keep in mind, we would really like the break-even at 30 much more than 120, because as you can see on this curve right here, everyone, we broke even here, we were making money, we were making money, we were making money, we made the most money, then we made too many things and they stopped selling and they're sitting on the shelf, and so we are losing profit, but we are still incurring costs. And so the 120 is breaking even again, and then after that we are in the red, we are going bankrupt. So we definitely don't want that to happen. And so let's talk about the next piece here. What level of production maximizes profit? And so we're looking for this high point right here, everyone. And so again, the way that I can do that in Wolfram is just type the word maximize in front of our profit function. And so for part B, I would say maximize negative x squared plus 150x minus 3,600. And we would get that the profit is maximized when at $2,025, when 75 units are produced and sold. And that's what we would want to do. Profit is maximized when, at 2,025 bucks, when 75 units are produced and sold. So again, for part A, we could have done revenue is equal to cost. We would have gotten the exact same break-even point. But for maximizing profit, which again is all that we care about in business, we say maximize and then the profit function, in this case, leading to 75 units, resulting in a profit of $2,025.